To understand about the velocity, you should be there with all the knowledge of speed. Okay, so this is what velocity. So what exactly velocity is? So in last class we have discussed about the speed. What we have defined, or how we have defined the speed. It is a distance traveled in unit second, or rate of change of distance with respect to time is called as what? Is called as speed. Now velocity. How velocity will be different? So suppose if you take a point A and here a point B. Okay. So suppose a person starts from here, going here. So this is what, say some 15 meter. But if you go directly, it is only 10 meter. Okay. So this actual path covered. You are not going in this direction. You are going in this direction only. The actual path traced by you is this one. Okay. So this path is what you actually traveled by you. So if we ask what is the displacement and what is the distance, this is what going to be your distance. And when you come here, you will check from your Google map or something what it will show. It will show some direct distance between A and B, or shortest distance between A and B. That is what we can say displacement. That is what we can say displacement. Okay. Now, how you calculated the speed? You will calculate the speed, this distance divided by time taken. Okay, distance divided by time taken. When you start from here to here, so let's say it will take some 10 seconds. You don't know how much time it will take from here to here, because you are not traveling in that path. You are traveling in this actual path. So you are taking 10 seconds. Somebody tell you, why you are going all these things? You must have come directly from here to here. It is only 10 meters, but you are already gone. So if this is what displacement, the shortest distance between A and B. So we are going to consider this displacement to define the speed. So sorry, no, not speed. It is a velocity. Then what velocity is? Velocity is, instead of distance, we have to take displacement. Displacement divided by time will give you what? It will give you the velocity. Okay. So suppose if you calculate the speed here, distance is what? 15 divided by 10. So you will get 1.5 meter per second. Here displacement is what? 10. But time taken is what? Time taken is 10 only, because you are not going only there. After reaching B, you will check the time. Oh, we have spent 10 seconds, like that. Okay. So this is what? This is going to be 1 meter per second. Okay. So what is velocity? Velocity is nothing but ratio of displacement divided by time. Here you are not going to concentrate on what path you are tracing. You are going to concentrate on initial position and final position. You will take that distance between initial and final position divided by time will give you the velocity. Okay. Then how we can define the velocity? So displacement covered in unit time. 10 meter covered in 10 seconds. So in 1 second, how much covered? 1 second. Sorry, 1 meter. That means what? Distance or displacement covered in unit time, or 1 second or unit second is called as what? Is called as velocity. So how you can define? You can define as the displacement of an object, or displacement covered by an object. Displacement covered by an object or particle in unit time. In unit time is called velocity. is called velocity. There is no much difference between speed and velocity. Okay. So now, or you can define like this also. You have defined the speed in two ways. So velocity also you can define in two ways. One more is what? Rate of change of. There we have used distance. Now we have to use displacement. So one more definition is the rate of change of displacement with respect to time. With respect to time is called what? Velocity. Is called velocity. Okay. So any definition you can go with whichever you feel easy. Okay. Now so what we got? We got it as velocity. So you can again denote it by v. Speed also you can denote by v, and here velocity also you can denote by v. So v equals to what is that? Displacement divided by time. Displacement divided by time. So see here, displacement is what? Again it is nothing but distance, shortage distance. So what is the unit? Unit of displacement is meter. So what is the unit of time? Unit of time is what? Second. So again what is the SI unit? SI unit is meter per second, or you can write it as meter per second. Okay. Or sometimes you can denote, you can use kilometer per hour. Meter per second or kilometer per hour. Any unit you can use. So for the velocity. Now displacement. Distance was what? Always positive. But displacement is what? Displacement may be positive, may be negative, may be zero. So if this changes, this will also change same according to this one. So velocity may be positive or negative or zero. It may be anything. If a particle starts from this point and again come back to the same point, so displacement is what? It is going to be zero. Displacement is going to be zero. So displacement is going to be zero means your velocity will go zero. But speed is not zero because distance traveled is not zero. Okay. So this is what exactly velocity is. Okay. But remember, we are in straight line motion. We are in straight line motion. So straight line. So remember this, very important. Since we are in straight line motion, particle will always move in the straight direction. Direction is not changing. If particle is moving in a straight direction, if this is A and this is B, what is the distance? Suppose say it is 10 meter. What is the distance? Distance is equals to what? 10 meter. What is the displacement? Displacement is also 10 meter. So displacement is also what? It's also 10 meter. That means for a straight line motion or for the one dimensional motion, distance is equals to what? Distance is most of time is equals to displacement. Not always, most of time. Okay, so most of time it is going to be equal. That means speed is most of time equals to what? Velocity. Speed is most of time what? It is equals to velocity. This we have to keep in our mind. Okay, since we are studying about the straight line motion, in many cases speed is going to same as the velocity. Okay, so this what we have to keep in our mind. Okay, so remember, for the straight line motion, object is moving in a straight line, so displacement is most of time going to be equal to distance. So if I take an example to calculate the velocity, suppose vehicle start from here. So it will travel. It will travel say some 80 kilometers. Some 80 kilometers. Okay. So to travel 80 kilometers, say it will take some 2 hours. So if you take some, you can take some 3 hours or some 2 hours. Okay. So again it will come back. So it will now vehicle is here. Okay. So it will change its direction. So it come back here. It will come around some 30 kilometers. So some 30 kilometers. Okay. So to travel 30 kilometers, it has taken say only 1 hour. It has taken say only 1 hour. Okay. So now if we want to calculate the velocity, this is what initial position. So this is what final position. So now what we want? We want velocity. They are asking us to calculate velocity. But what is velocity? Velocity is displacement divided by time. See here. It travels 80 kilometers, then 30. 80 plus 30. Okay, so say it is 110. But that is what? That is the distance. But what is in the formula? Displacement. So displacement is what? Distance between initial and final position. This is what your displacement. So how much it is? Total is 80 minus 30. Getting the point? From here to here it is 80. Subtract 30 in that one. This is what going to be. So 80 minus 30 is going to be what? 50. So your displacement is what? Displacement is 50. Time taken is same. From here to here 2 hours. To come here 1 hour. So total time taken will not change. So time taken is same for distance and displacement. Okay, so time taken is here 2 hours, here 1 hour. So how much it has taken? It has taken 3 hours. This is what? Kilometer. Okay. So what we got is, we got 50 divided by 3. So what you will get? You will get it as 1. So 3 6 is 80. So again 6 kilometer per hour. Means 16.66 kilometer per hour is going to be what? It is going to be your velocity. Okay. You can write kilometer per hour. As we know that if it is given in meter and second, you can write meter per second also. Okay. So this is what. So here if you want to calculate the speed, speed is what? 80 plus 30. So 110 divided by time taken is what? Time taken is 3 hours. So 3 ones are, so 3 3s are 10. So this will become, this is 9. This will become 20. So 3 6s are, then again 60. So distance, what your speed is more than what? Your velocity. Remember, most of time speed is going to be more than velocity, because distance is always what? Greater than or equal to displacement. We know that distance is always greater than or equal to what? Greater than or equal to displacement. So that is why speed is also always greater than or equal to what? Greater than or equal to velocity. Okay, or velocity is always what? Less than or equal to speed. Okay, so this is what you have to remember. Or speed divided by velocity, you can say always greater than or equal to 1. However you want like that, we can change. Okay, so I will not spend much time on this one. Same as what you are discussed in the speed. You have to just change distance by displacement. Okay, so now I will go into the types of velocities. So what are the types? So first one is same as the speed. What are the types of speed? Uniform speed, non-uniform speed, what average speed and instantaneous speed. Similarly here, uniform velocity. Second one is non-uniform velocity. Third one is what? Average velocity. And fourth one is instantaneous velocity. So instantaneous velocities. Okay. So these are the different types or 4 types of velocities: uniform velocity, non-uniform velocity, average velocity, and instantaneous velocity. Go one by one. That is first one. That is what? Uniform velocity. So what is the uniform velocity? So this will happen when we are in straight line motion or motion one dimension. So suppose a vehicle going in a straight direction. So there is not much difference between uniform speed and uniform velocity. Okay, so both are one and the same. So it is going here. So now it is moving in straight line means they will check after 2 seconds. So displacement is what? Displacement is 5 meters. Again they will check after 2 seconds. Displacement is again 5 meters. Again they will check after 2 minutes. Displacement is what? 5 meters. Again after 2 seconds. Displacement is what? 5 meters. Okay. So straight distance you have to measure. So this is what displacement is 5. So I will write displacement here. So displacement. This is what? Displacement. So this is what? Time taken. So what is velocity? Velocity is displacement divided by time. So 5 by 2 it is what? 2.5. Here 5 by 2. This is also 2.5. 5 by 2. 2.5. 5 by 2. So 2.5. So what is that? Meter per second. Okay. So if you check velocity values are same. 2.5. That means the same velocity the vehicle is maintaining. That means velocity is uniform over the whole journey. Okay. But how we can define it? How we can define it means it is traveling what? It is covering the same displacement. So it is covering equal displacement. This displacement is equal to what? This displacement. In what? In equal interval of time. Time is also what? Time is also equal. In equal interval of time, object is covering equal displacement. So that kind of motion we call it as uniform velocity. Okay, so how we can define? If an object covers equal displacement in equal interval of time, in equal interval of time, then it is said to be in uniform motion. Then it is said to be in uniform velocity, or it is said to be having uniform velocity. Okay, or then motion is called as uniform velocity, or then velocity is called as uniform velocity. However you want like that, you can change the definition. This is not going to be definition of uniform velocity. Okay, so in uniform speed, equal distance in equal time. In uniform velocity, equal displacement in equal interval of time. Okay, so that is what the uniform velocity. I'm not going to solve more problems on this one because same as I have discussed in the speed. Okay, so next is what? Next is non-uniform velocity. This is very important, non-uniform velocity. So non-uniform velocity in the sense, what will happen here? Even the body is moving in a straight line. So they will check after 2 seconds. So if you take a vehicle over here, okay. So displacement I will take here and time I will take here. They will check after 2 seconds. So displacement was what? Displacement was obviously 5 meter. Again after 2 seconds they will check. Displacement was same. Displacement was suddenly 10 meter. So again they will check after 2 seconds. So displacement was 4 meter. Again they will check after 2 seconds. Displacement was 6 meters. So it was very big. In an equal interval of time, it is covering unequal displacements. Displacements are not same. This displacement and this displacement are not equal. But time are what? Times are equal. Okay. So if you check the velocity, 5 by 2, 2.5 meter per second, 10 by 5, 5 meter per second. So 4 by 2, 2 meter per second. Okay. So 10 by 2 is 5, 5 by 2, 2.5. So 6 by 2, 3 meter per second. So if you check the velocities, all have the different values. That is not maintaining the value of velocity uniform. So it is what? Non-uniform velocity, or it is also called as what? It is also called as variable velocity. Okay. So then how we can define it? You can define it two ways. If an object covers unequal distances in equal interval of time, it is called as what? It is called as non-uniform velocity. Or if object covers equal distance in unequal interval of time, then also it is called as what? It is called as non-uniform velocity. Don't get confused, we will pick only one. What is that? Equal displacements in unequal interval of time, not distance displacements. Okay. So what you can write? If an object covers unequal displacement in equal interval of time, then velocity is said to be or is called what? Non-uniform velocity or variable velocity. Non-uniform velocity or variable velocity. Okay. So this is what the definition of non-uniform velocity. But one thing what we can understand here is, if here what? Distance and displacements are same, there also distance and displacements are same. Here speed is not same means, so if speed is same, velocity is also same. Here speed is not same, so velocity is also not same in straight line motion. Sometimes like this also happen. Object may be in uniform speed, but not in uniform velocity. How this will happen? If object changing its direction continuously, see here, it will cover the same distance in same time. So 5 meter, I will take 5 meter in 2 seconds, 5 meter in 2 seconds, 5 meter in 2 seconds, 5 meter in 2 seconds. Try to understand this one. Point A, point B. Now, if we calculate the velocities are speeds are same, 5 by 2, 5 by 2, 5 by 2, 5 by 2. But if you calculate velocity may not be same, because here this is not distance, this is displacement. This is what displacement, it may not be equal to 5. Here displacement is this one, here displacement is this one, here displacement is this one. If you look at the diagram, displacements are same or different? Displacements are different. These distances may be same, but these displacements are what? Displacement are different. So velocity will be different. Here what? Speed is same. This is uniform speed. What we can say? Uniform speed. Getting it? This is uniform speed, but not uniform velocity. Why? Because direction is changing continuously. Why we are getting different displacement? Because direction is changing continuously. Then what we can understand is, even though speed is same, if object is moving with different directions or it is changing its direction continuously, then also we can call it as non-uniform speed. So I can add that definition also here. So I will give one more definition. What is that? Object in a uniform speed, if it changes, if an object in uniform speed changes its direction continuously, then velocity is what? Then also velocity is non-uniform velocity. I hope you are getting it. Same will happen with what? Same will happen with your circular motion. When object starts from here, it may be same speed everywhere, but when it comes to the same point, velocity is going to be what? 0. So if you change, if you check the displacement, here displacement is different, here displacement is different, here displacement is different, here displacement is different. So you will get what? You will get a different velocities. But speed is going to be what? Speed may be uniform. Okay, that depends on the person who is driving the vehicle. Okay, so remember, if object is covering equal distance in equal interval of, or equal displacement in equal interval of time, then also it is not uniform speed. Even it is having the same speed, but if it is changing its direction continuously, then also what? Then also it is going to be non-uniform velocity, but not uniform. Is, as you know, average velocity. So what is average velocity? You know about average speed, total distance divided by total time. Same thing here. Average velocity is what? Total displacement divided by total time. So suppose there is an object. So for t1 time, it will take d1. This is not displacement, not this one. So from here to here distance and displacement are same. So d2 in t2 from here to here, d3 in t3 again from here to here. So d4 in time of t4. Okay. So displacement. So this is point A, B, C, D, E. Displacement between A and B is what? D1. Displacement between B and C is what? D2. This direct distance you have to consider. Here D3 between C and D. Between D and E it is D4. Okay. So now if you want to calculate the velocity, so velocity is equals to total displacement d1 plus d2 plus d3 plus d4. d1 plus d2 plus d3 plus d4 divided by t1 plus t2 plus t3 plus t4. So how we can define? Simple. It is the ratio of total displacement total displacement to total time taken. It is the ratio of the, or you can say the ratio of total displacement to total time is called average velocity. Is called average velocity. Okay, so you can denote it by P average. P average is equals to total displacement divided by total time taken, or just you can say total time. So total displacement to the total time, we call it as what? We call it as average velocity. Okay, so examples you have seen in this speed. Again we will discuss. We will take some examples also, but as of now you remember total displacement divided by total time. Okay, so I will go with next one, that is instantaneous velocity. Instantaneous velocity. Okay. Now suppose there is a path like this. Okay, so from A to B, it has taken, say here time was 0, here time is say 10 seconds, so total 10 seconds it has taken. So this is what the displacement, so this displacement say maybe some 20 meter. So 20 meter divided by 10 will give what? It will give the velocity. But what you want? You want instantaneous velocity. Instantaneous velocity means say you want velocity at t equals to 5 seconds. Exactly at 5 seconds, what is the velocity you want? Okay. For that, what you have to do? You have to divide the time. So total is what? 10. So what you have to do? You divide by 10. So 1 second. Again you go on dividing. If you go on dividing, if in 10 seconds it travel 20 meter, means in 1 second it will travel what? It will travel how much? It will travel 2 meter. Okay. So you want exactly at this point, at 5 seconds. So you go on dividing your time. That means you go on dividing your distances. As you go on dividing your time, obviously your distance will go on dividing. In 10 seconds 20 meter, in 1 second 2 meter, in 0.1 second 0.2 meter. As you make your time very small, your displacement will also go on very small. So for that, what you have to do? Very small distance you have to take, delta x, for very small time, delta t. So your instantaneous velocity, V instantaneous, is equals to what you can write? You can write small displacement divided by very small. How much small? For that we have to give the limit. What limit you have to give? You have to give limit. How much small? That time is very much small. How much? It should be nearly, it is tending to become 0. Delta t is very close to 0, 0.0001 second. How much distance displacement cover, that we want. So we will put one limit. What is that limit? Limit is delta t tends to 0, delta x divided by delta t. This is what instantaneous velocity. Most of the time this will help us to calculate. This is also write it as dx by dt. You will understand what is dx by dt next when you will learn differentiation. So as of now you remember, instantaneous velocity is what? The velocity at any given instant of time. That is what? Dx by dt. So how we can write the definition? Velocity at a given instant of time is called instantaneous velocity. Is called instantaneous velocity. Okay, so as of now remember this much. So we will discuss again, we will spend some time with some examples. So as of now you know it's all the types of velocities and what exactly velocity is. Okay. See you in the next class.